Welcome to the second part of Competency 11 quiz questions. In this video, we will answer questions related to geometry and measurement. Number 7. The surface area of a cube is 337.5 inches squared. In cubic inches, what is its volume? Okay, they gave you a hint right here. Probably won't get that great hint when you're taking a practice test or the real test because you should know that volume is cubic regardless. Okay, so what do we really have going on here? We know that every cube equals 6s squared, okay? And in our case, they're giving us the value, okay? All right, now, if we divide both sides by 6, right, we will actually be able to just pop this in the calculator, put all that under the radical, 337.5, and divide the whole thing by 6, okay? So let's do that. But that'll just give us a value of the side. To get the volume, we need V equals S up to the third, okay? All right, so let's say second radical, and then 337.5 divided all by 6, and we get our side value. Now, just don't do anything else with it. Oh, but I did. I just hit something. I have to be careful. All right, let's go second mode. Get out. Second mode. Okay, let's see if it'll still work because I messed with something. Okay, so we want to say pair it up and it'll still work. Oh, thank goodness. Pair it up, put your 3 in, and there we go. And that gives us a value. Now, I disagree with them rounding. I would have just left that answer at 0.875. Okay, that's more accurate, but that's not what they did. Okay, so let's go to number 8, and it says, the lateral surface area of a regular pyramid with a square base is 2,100 centimeters squared if the lateral height is 20 centimeters. How many centimeters is the length of one side of the base? Okay, giving us a regular pyramid is fabulous. So what do we really have here? We have 2,100 equals, okay, all right, so how do we get surface area of a pyramid? The top part is your lateral. That is 4 triangles put together. And the base will be a square, okay? So let's get that done. Okay, so that area will be 4 triangles, and those triangles are equal to the base times, now they gave us our lateral height right here, okay? B times 20, all divided by 2, okay? Now plus B times B, okay? That's because the bottom is square, so that's side times side. We're calling it base times base, okay? Now, we could rewrite all of this. The first thing I need you to point out to you is that this can be simplified, and this could be turned into a 1. If I did a better job, I'll just mark it out and put a 10 over here, okay? Now, let's rewrite this and clean it up. What are we really looking at? We're looking at this. B squared plus 4 times 10, okay? 4 times 10 is 40. B. Oh, and it's not plus. Okay, we want to move it all to the same side. Okay, this is a B. Minus 2,100 equals 0. Okay, and I hope you're used to seeing these kind of things. Um, I saw it right away, and I'll tell you why I saw it right away. That b squared. I saw a b squared added to something with a b on its own. And that was like a huge hint for me that, hey, you're going to have a quadratic situation coming up. Okay. Now, that being said, we need to realize that in our calculator, the fact is b can be x. A variable is a variable. X in our calculator can really stand for any variable. And because we have one variable being used, we're good to go. Okay, so let's go over to our calculator. All right, and we are going to put in, go to your X, your Y equals, clear that out. And we will say X squared plus 40X minus 2100. Okay, now I'm going to be honest with you. Try to graph that. Okay, we can't even see it because the numbers are so huge. And yeah, we could go zoom and we could say zoom in and we could enter and we could enter and enter and enter. Good luck. You know what I'm saying? And we could go with the window. Okay, no, sorry about that. Just push window. And this looks like the numbers are very small. So let's do a minus 100. Okay, delete those others. Go down here. I'm going to push clear and put in 100. And then I'll go down here and clear. Remember to put back your negative. And I'm going to say 100 and 100. And again, I'll reiterate, do not change anything else here, okay? So now let's go with a graph. Okay, it gives us something we could trace, okay? And it kind of lets me look at what we have. So I'm going to go trace, and I'm going to arrow over. Let me see my trace. I think it's way down at the bottom. Oh, there it is. There it is. It's back. It's back. Did I go too far? Okay. It's really, okay. It's having issues. But if you see the Y is getting close to 30, okay, I'm going to push it one more time and see what happens. Ugh. So somewhere near 30. Okay, well, let's not mess with that. Okay, this is what we do know. Okay, we're going to actually use the table. And we know by looking at this with all these zeros, we know that we could factor this out. And we have B, and we have B, and I'm saying that it might be near 30. So do this. Say second graph, and you probably already can tell what the answer is. I know. And you look at your answer choices. You're looking at your options and you're saying, hey, lady, 21. If you just look at the 21, you're saying 3 times 7 is 21. Yes, absolutely. So what do we really have? We have plus 30 here. And then I'm going to say minus, no, other way around. Minus 30 plus 70. Minus 30 plus 70. And you saw your graph, you probably do that. But let's do this. Let's go right to the value of 30 in our table. Okay, so let's do second window and let's go to 30. Okay, and I always like to push enter to make sure it's in there. And now second graph. And look, that's where we have a root. So we do have a root at 30. Okay. Now we could go over to, oh, that should be plus 70. I just realized I didn't put my plus in there. Okay, now it's right. Okay, so let's go to minus 70. Let's go back to our window. Second window, minus 70. Okay, I'm going to push enter. and then second graph in our table, and that is correct. So we have two issues going on here. We don't want the negative 70, okay? And there's a lot of ways to test that, but one big thing is that it's not in our answer choices, and D is the correct option, okay? Because we have B equals, I'll go ahead and write that out. B equals minus the 70, and B equals the 30. So we know that this is the option that we need to keep, mainly because we have a negative 70, and it's not in our answer choices. Okay, number 9. The volume of a cylinder is 2,400 centimeters squared. If the height is twice the radius, what is the height in inches? Okay, so we know that the volume is, let's go ahead and just write that on the side. We know volume because they say, what is the height? And we're talking volume right here. Okay, so we have pi r squared. That will be the bottom part of the cylinder times the height. Okay, whatever its height is. Okay, now, so let's get this written out. We go ahead and just use that and say pi r squared. What is the height though? They're saying the height is 2r, and that all of that equals the 2,400. All right, let's do a little rewriting over on the left side. Okay, so what do we really have? We have 2 pi r to the third equals the 2,400. Now, before I go on, I'm going to look over here at my answer choices. And I noticed pi is not hanging out on its own. And in other videos, when I would tell you, hey, look, over in our answer choices, pi is hanging out like a variable. Well, for us right now, he is not hanging out like a variable, and that is highly important, okay? For our calculator use, we have to make sure we do this correctly, okay? So what do? We divide both sides by 2 pi, okay? And that means 2 pi, all right? So, of course, we have some cancellation. Now, to get the value of r, we need under the cube root, we need 2,400. Now, we have to glue 2 pi together when we enter it in the calculator. We have to use parentheses. Think about it. That will mess up our order of operations. When we let it hang out like a variable, we don't include it. We push it off to the side. We can't allow pi to be pushed off to the side. If you do that, you will get a disaster. Okay. Now, also, it says that the height is twice the radius. So we know that our height equals 2 times r, okay? So we have to keep that in mind after we get our r value, okay? So in our calculator, we need to go second mode to get out of that, okay? We need to go grab the root, the cube root. So the general root is alpha window, and that is number 6, okay? Now we need to put in a 3 for our cube root, and then we have 2,400 divided by parentheses 2, second, carry it up, gives us our pi, close your parentheses. Now push enter. And that gives us an estimation of our radius. So we need to take that value and times 2, double it. So times 2 equals. And yes, I see a rounded value, option B, that works, and that is actually the correct value. Okay. All right. So let's move on to number 10. Number 10. The area of each circular base of a cylinder is 100 pi units squared. If the height is 13 units, what is the total surface area? Okay, there's a few things that we know are going on here. A very important point is that we're talking about area of this base. Okay, and because it's area, we have this squared here. So I know that the area of the base, it's a circle. Okay, it's always two circles, top, bottom, like a soda can. All right, so that is pi r squared. Well, here's my r squared, so I know r equals 10. They've given me the value of the radius. Okay, so now another thing that we know. We know that it's flattened out. We did that in another video when it's flattened out. And this is my 100 pi. And here's another 100 pi. But this rectangle here, okay, this value here, okay, this will be your height. But our base, we know, is the circumference that goes around the whole circle. So that is 2 r pi. Okay, for us, we know what r is. So 2 times 10 is 20 pi. So we know our r, we know our base, we simply, okay, and we know our height. Okay, so they're giving us that as equal to 13. We know a lot, right? So we can go ahead and just solve this. Not a problem. So let's just give it all out, write it all out, and just put this in the calculator. Not a big deal. Okay, so we have our surface area equals 2, that, okay, we have a top and a bottom, 2 times pi r squared, okay? Then we have to add that to this rectangle. So that's our top and bottom. Now our rectangle, which is our lateral surface area, the part that goes around the soda can that you pick up when you pick up your soda, that is 2r pi times whatever that height is. So for us, what do we have? We have 2 times, okay, well, we've already said that that's 20 pi. So 10, okay, wait a second. Oh, no, that's not 25. That's our 100. But I'm going to go ahead and say 10 squared, okay, pi. Just so you see what this should look like in other situations. So then 2 times the 10 pi, okay, this all multiplied together, and then our height is 13. Okay, we could simply put this in the calculator like this. The only issue is you may not see the pi needs to hang out on its own like a variable, which we've already discussed, because of our answer choices are telling us that. All right, so let's clean it up a little, and we could do it like this. And that's our pi. And then add that to 20. 2 times 10 is 20 times the 13 pi. And we will allow pi to hang out on its own. So what we need to do is just calculate those coefficients. Well, let's go ahead and add those up, okay? So in parentheses, 2 times, well, you know what? Let's go ahead and do 10 squared. So you see that it works. I don't know how many videos you've watched with me, but sometimes it's better to type in what you know or what you have exactly instead of trying to do it in your head. Okay. I keep trying to make that point again and again, and that's because of experience. You get tired. So now we could just do the 2 times 10 times 13 and close our parentheses. Now let's push enter, and that gives us 4 160 pi, which is option A. And that is correct. Okay. Let's go to number 11. All right. So we have the area of the base of a cone is 225 pi inches squared, and the volume is 1,875 pi inches cubic. What is the lateral height? Okay, we have some good things going on here. We have a area of a base, which is another circle. So we have the value of r again, right? So, however, and that gives us r equals 15. But this is for a cone, and they're asking us for some different situations here. So let me draw a cone real quick and make my point, okay? So we have our cone, we have our circle. Then we have this situation coming up here. Okay. So this is 15. Okay. And we have our height, and this is our lateral. Okay. Before we can solve for the lateral using our Pythagorean theorem, we have to solve for the height using the formula for volume. Okay, so let's set this up over here on the side. L equals, under the radical, 15 squared plus, I have no clue, okay, height squared. But once we get the value of the height, we can square it and put it under in the calculator under the radical, and we will have our solution. Okay, so what do we really have here then? Okay, we come over here and they are giving us 225 pi times the height. You're going to divide all that by 3. Now that's the formula. We're using the formula for a cone. Okay, now that entire volume equals the 1,875 pi. All right, so how do we begin? Multiply both sides by 3 to get rid of that denominator. We don't want that denominator to be there. Okay, times 3. Cancel our 3's, and we shall clean all this up. Okay, so let's do this. 225 pi times the h equals 3 times 1,875 pi. Divide both sides by your 225 pi. 225 pi. Okay, so this cancels. For simplicity, let's cancel out our values of pi. What are we going to put in the calculator? This is what goes in the calculator. That will give us a height, okay? Okay, so what do we have? We have 3 times 1,875. Divide that by our 225 and push enter. Okay, that's a nice clean number, 25. Remember, that's just the value of our height. Come over to where we set this up over here, and that means that we need to have 25 squared. So our height equals 25. So we need to find the lateral height. So which, if you look at what I've drawn, of course, you realize that that's Pythagorean theorem and that L is our hypotenuse. Okay, so now we say second radical, and under our radical, we have 15 squared plus 25 squared. Double check how you enter. Double check that I entered correctly. Yes, I did. Push enter, and that gives us the correct value, which happens to be option C. Okay, very nice. Okay, let's go to number 12. If the surface area of a sphere is 25 pi units squared, what is the volume in, I think that's supposed to be in units squared. It's nice to be able to fix stuff right on the fly. Okay, but anyway, we've got it. We've got it corrected. It was a little typo. But we move on. Right. Okay. Well, you know what's great about this also? This question is saying area, and they give us a value with the area. Okay. But here's the thing. We can't just pop in with this surface area here and say, oh, R equals 5, because 5 times 5 is 25. That's not going to work because we're talking sphere. Okay. And let me go through this process with you. Okay. I always remember the surface area for a sphere. It is as the first derivative of the volume of a sphere. I know that's a very weird, geeky way to do it, but this is how I remember it. It is the first derivative, which gives me, okay, first off, the volume is equal to this, right? The volume is 4 pi r to the third divided by 3. So that gives me, using the chain rule, 12 pi r squared. Divide that by 3, and that gives me, okay, 4 pi r squared. Okay. Now, that area, they're telling us it's equal to this. So that's 25 pi. So what do? We divide both sides by 4 pi. Divide by 4 pi. This cancels. Now I can cancel my 2 pi's over here. Pi cancels out on the right side. So I have R equals, under the radical, 25 divided by 4. Okay, so let's go to our calculator. I know you're saying, I can do that in my head. Well, that's all well and good, but let's go do it in the calculator. So second radical, and we have 25 divided by the 4. Press enter and push math, enter, enter again. And that does, yes, I agree, 5/2. So we know that I'm going to write it over here, 5/2. Okay, so that gives us our radius. So be careful. The minute you have the issue with a sphere that is 3-dimensional, you cannot use 2-dimensional situations like a base, which is from number 11. Think about it. That's a flat. The base part of the cone was a flat 2D. A sphere, that's giving us a whole other 3-dimensional situation, not as simple. Okay, now we can go on and actually solve this pretty easily now. We have that the volume equals, what does that equal? Okay, now we're going to use the formula of our volume. 4 pi r. Okay, I'm going to get rid of this right here so we have room. Okay, pi. And then we need to take our 5/2 to the third power, and it's all divided by 3. Okay, now let's, as I said, let's look at our answer options. Well, guess who's hanging out on the side again? It's in terms of pi. So we want to make sure we leave him in this situation he's got to hang out on his own for a while. So 5 over 2 up to the third. So leave our pi out of the situation and enter everything else into the calculator like we've done in other videos. So we have 4 parentheses, 5 divided by 2 parentheses, carry it up to the third. We got to arrow over because it's flashing with that arrow. It's telling us what to do. Okay, now we divide that by 3, push enter, and lo and behold, we've got an option. And it flat tells us right here that that's supposed to be a 3 repeating. Okay, so obviously option C is our solution. Okay, this is the last question in this video. And once again, thank you so much for watching. I love the support. I'm starting to see a gain in support. You guys are amazing. So remember, like us. That tells me how I'm doing and how my help is doing. Okay, that tells us how we're all doing. And it'll help us keep these free. Share with a friend because it looks like you're sharing and people are subscribing, which is amazing. And thank you for subscribing. And again, happy testing.